Today's lesson is on adding and subtracting rational expressions. Previously, we looked at multiplying and dividing rational expressions, and we began by reviewing how to multiply and divide fractions. We're going to do the same thing today. We're going to review adding and subtracting fractions, and then use that to help us add and subtract rational expressions. So when we add and subtract fractions, the most important thing is that we have to have a common denominator. If it doesn't have a common denominator, we cannot combine them by either adding or subtracting. Once we have a common denominator, then we're going to add or subtract our numerators, kind of like we did with multiplying. When we multiply straight across, we're just going to either add or subtract straight across the top, but we keep our denominator. It stays the same. Whatever our common denominator was is what we will end up with. So we're going to look at least common multiples. So LCM stands for least common multiple. So the easiest way to do this is to start listing multiples of each number and then find where they overlap. I usually do 3 to 4 of each number. And then if I haven't found a pair by then, I keep going. So for 4, the multiples would be obviously 4, 8, 12, 16. And then I'm going to do the same thing for 10. I've got 10, 20, 30, 40. So I haven't quite found a multiple yet, so I'm going to go one more for 4. The next multiple would be 20. So I see that's in both of my columns. So my least common multiple is 20. I'm going to do that each time. So I'm going to start off just listing a couple of numbers. You can go as high as you think you might need to. In this case, I'm going to go to 50 just because I know that for 25, the first time that it ends in a 0 is going to be 50. So I had to go a little bit further with my first column. But that told me that my least common multiple was 50. All right, for 24 and 32, I've got 24, 48, 72, 96, so there's 4. And then 32, let's see, 32, 64, 96, and there is our common multiple, 96. Okay, so when we're finding those, that's the least common multiple is going to be what we are looking for, what we're using. So that's what we're going to find. Our least common, instead of calling it our least common multiple, since we're using it as our denominator, we're going to call it our least common denominator. Or the LCD. It's really the same thing. It just helps us remember that it's going to be in the denominator in both of our polynomials that we're adding or subtracting, as well as our answer. So if you look at this little box, it says to find the least common multiple of polynomials, we want to factor. Told you guys, factoring never goes away. We're going to factor it completely. If we have any repeated ones, we're going to use powers. So, for example, this one would be written as x plus 3 squared instead of x plus 3 times x plus 3. And then here's the other thing. If they have common factors, and that could be just a variable or it could be a factor like x plus 3, you're going to use the highest power for each factor. So let's take a look at how that would work out. So problem A, I've got 2 and 3. Those are my constants. I've got x cubed and x to the 5th. And I've got y to the 4th and y to the 3rd. So starting off with my constants. So for 2, I'm going to go 2, 4, 6, 8, 10. For 3, 3, 6, 9, 12, 15. And I can see that the first number that they have in common is 6. So my least common denominator here is going to start off with 6. Then I'm going to look at my x's. Now, we said that we're going to look at the highest power. So of these two, x to the 5th is the highest power. So that automatically becomes part of my answer. The same thing for y. I've got y to the 4th and y to the 3rd. Well, y to the 4th is the greatest power. So that automatically becomes part of my answer. Okay, but what about if we have to factor some things? Okay, so we're going to go through, we're going to go ahead and factor these. So this is going to factor to x minus 1 and x plus 4. And this one is going to factor into x minus 1 and x minus 2. So my least common multiple, I have x minus 1 twice, but I don't need to list it twice. I'm only going to list it the one time. Then I have x plus 4 and x minus 2. All right, C, we're looking at, again, we've got constants. We have x values, and we have y values. So for 4 and 3, it would be 4, 8, 12, 16, 20. 3 is 3, 6, 9, 12, 15. And I see that 12 is my least common multiple. For x, my greatest exponent is 5, so I'm going to use x to the 5th. And for y, my greatest exponent is 7, so I'm going to use y to the 7th. All right, C, we're going to factor these. This is a difference of squares, so x plus 2 and x minus 2. And then I've got x plus 2 and x plus 3. So my least common multiple, or least common denominator, would be x plus 2 times x minus 2 times x plus 3, because I do not have to include this again. It's already there once. For E, 4 and 16, this one's kind of nice because 16 is a multiple of 4. And so that is obviously going to be our least common multiple. For x, I've got x squared and x to the 4th, so I'm going to use the highest exponent, x to the 4th. And for y, I've got y to the 3rd and y, so I'm going to use the highest exponent, y to the 3rd. All right, and this one, we've got another difference of squares, so x plus 5 and x minus 5. And then this is actually a perfect square trinomial, so x plus 5 times x plus 5. So my least common multiple is going to be x plus 5, x minus 5. And this time I am going to need to include the second x plus 5, because the first time they have it in common. But this second one still needs to be multiplied. So I would have to include that one. And then you could use your exponents like that. All right, so let's practice adding rational expressions. We are going to need to create a common denominator. So usually I'm going to go and I'm going to go ahead and factor the denominator and see if the other one has a common factor at all. So when I factor this, I get x plus 1 times x plus 2. Well, the second expression here, this already has an x plus 1 in the denominator. So what I'm going to do is I'm going to multiply by x plus 2, and I have to do that on the top and the bottom. All right, so when I multiply x times x plus 2, I get x squared plus 2x. Then my denominator is x plus 1 times x plus 2. And now that I have a common denominator, I can just add these across. So I've got x minus 1 plus x squared plus 2x. So I'm going to get x squared plus 3x minus 1 over x plus 1 times x plus 2. You could also write the original denominator if you wanted to, rather than the factors. Either way would be fine. All right. So over here, we've got, this is 2 times x minus 1. And this one would be 3 times x minus 1. So they do have this x minus 1 in common. But now we need to get this 2 and this 3 to be equal. So I'm going to take this first factor, this 3x over 2 times x minus 1. I'm going to multiply that one by 3 over 3. And that 3 came from the second term. So I get 9x over 6 times x minus 1. Then this one, 3x minus 2 over 3 times x minus 1. I'm going to multiply by 2 over 2. And that 2 came from right there. So I get 6x minus 4 over 6 times x minus 1. So now I can add these. I'm going to add the numerators. So it's going to be 9x plus 6x minus 4 over 6 times x minus 1. which simplifies to 15x minus 4 over 6 times x minus 1. All right, this one is going to be a little bit more complicated because these denominators are already as factored as they can be in real numbers. We know that we can technically factor that sum of squares, but it gives us imaginary numbers. So what we're going to have to do is we're going to have to take each factor and multiply it by the denominator from the other factor. So I'm going to do that with this one first. So x over x plus 3. I'm going to multiply that by x squared plus 1 on the top and the bottom, so that I get my common denominator. So x times x squared plus 1 gives me x cubed plus x. Now I'm going to do the same thing, but I'm going to take this factor and I am going to multiply by this denominator on top and bottom. So I'm going to end up with x plus 3 times x squared plus 1 on the bottom. The top is going to give me negative 18x minus 54. So now I can add these together. So I'm going to get x cubed plus x minus 18x minus 54 all over my new denominator. That was weird. And then I can simplify that. That becomes x cubed minus 17x minus 54 over x plus 3 times x squared plus 1. For these, it does not matter which order the factors in the denominator go. If it was x squared plus 1 times x plus 3, that's perfectly fine. Excuse me. Last one. So first thing I want to do is I want to factor this denominator. That is a perfect square trinomial, so it is x plus 3 times x plus 3. I also want to go ahead and factor the top. So that is 2 times x plus 3. Well, with this one, I have a common factor on the top and the bottom of x plus 3. So I can cancel those out. That becomes a factor of 1. So now I have x over x plus 3 plus 2 over x plus 3. So here we already have a common denominator. So I don't have to worry about that. So I can literally just add the numerators. So this is going to be x plus 2 over my common denominator of x plus 3. All right, let's do some subtraction problems. We're going to solve these pretty much the exact same way. The only difference is you want to distribute the negative sign for the subtraction. We're going to distribute that. So I'm still going to start off the same way by factoring where I can. The first thing I want to do, though, is I want to find that common denominator. So I'm going to factor this right here and see what I need to do to get a common denominator. This is the difference of squares, so it becomes x plus 2 times x minus 2. Well, this factor over here already has x plus 2 and it's in the denominator. So what I'm going to do is I'm going to multiply by x minus 2 on the top and the bottom. So I've got 2x squared minus 16 over x plus 2 and x minus 2. And I'm going to end up with x squared plus 2x minus 8. Over x plus 2 times x minus 2. All right, so I'm going to take this, distribute it in 3 places because there are 3 terms. So when I write this, I've got my 2x squared minus 16 minus x squared minus 2x plus 8. And then we are going to simplify as much as we can here. So 2x squared minus x squared gives me x squared. This minus 2x is the only x term I have. And then negative 16 plus 8 gives me negative 8. And then we do want to see, hey, can this be simplified? Or can this be factored? And it can. This becomes x plus 2 and x minus 4. And now we have a common factor on top and bottom of x plus 2. So that becomes a factor of 1, leaving me with a simplified answer of x minus 4 over x minus 2. All right, for B, same process. Once again, I see that I've got a difference of squares here. So this is x plus 8, x minus 8. Since I already have x plus 8 over here, I am going to multiply by x minus 8 on the top and the bottom. So I get 2x squared plus 64 minus x squared minus 12x plus 32. And that's over my common denominator. Now I want to distribute this negative. So I get 2x squared plus 64 minus x squared plus 12x minus 32 over my common denominator. I'm going to clean up my numerator. 2x squared minus x squared gives me x squared. And then I've only got one x term, that 12x. And then 64 minus 32 gives me 32. And now I'm going to factor my numerator. So this factors to x plus 4 times x plus 8. again over my common denominator. And now I have a factor I can cancel. I have x plus 8 on the top and the bottom. That becomes 1. So my final answer is x plus 4 divided by x minus 8. All right, our last one. All right, unfortunately, these do not have any common multiples, so I am going to have to take each factor and multiply it by the other factor's denominator. So I'm going to take 3x minus 5 over 2x minus 5. I'm going to multiply that by 3x plus 1 on top and bottom. So that gives me 9x squared, let's see, minus 12x minus 5 over my common denominator. Right, I'm going to do the same thing for this second factor. So 2x minus 5 over 3x plus 1. I am going to multiply that by the first factor's denominator. So 2x minus 5 over 2x minus 5. So I'm going to get 4x squared plus 20x, nope, sorry, minus 20x, plus 25 over the common denominator. All right. So 9x squared minus 12x minus 5. And that is then subtracting 4x squared minus 20x plus 25, which is all over my common denominator. I'm going to distribute this negative. So 9x squared minus 12x minus 5 minus 4x squared plus 20x minus 25 all over my common denominator. And 9x squared minus 4x squared gives me 5x squared. Negative 12x plus 20x gives me plus 8x. And then negative 5 minus 25 gives me negative 30 over my common denominator. And now we could try to factor the numerator, see if it works using bottoms up. So we would have a times c on the top plus b on the bottom. 5 times negative 30 gives me negative 150. My b value is 8. And I'm not going to list all of the factors here. I am just going to tell you that this is not something that factors. So we're just going to leave it like that because this doesn't work, cannot factor. So we're going to leave it like that.